If you look at a typical high-traffic airport today, you'll see a very specific rhythm. Airlines rely heavily on small, single-aisle jets, completing dozens of short, regional hops back and forth every single day. But Hong Kong International Airport operates on an entirely different scale. Look out across the tarmac here, and the narrow-body planes are dwarfed by an endless lineup of massive, wide-body leviathans. This animated map of Hong Kong's airport footprint highlights a serious geographic bottleneck. The facility sits on a heavily constrained patch of reclaimed land, yet it is forced to process an enormous volume of global traffic, demanding access to the region. Because you can't simply build more runways on an island with limited space, airlines have to maximize the payload of every single departure. They do this by deploying 3 distinct classes of heavy wide-body aircraft. Operating in Hong Kong means bringing the largest machines on Earth to make sure every available runway slot generates the absolute maximum economic return. The first category commanding space on the runway is the high-density passenger Titan. These are the absolute largest commercial vehicles in the sky. Airlines face a brutal math problem on their intercontinental routes. They need to move thousands of people between major global financial hubs within highly restricted daily time slots. To solve this, carriers like Singapore Airlines and EVA Air deploy massive airframes like the Airbus A380-800 and the Boeing 777-300ER. This cross-section data visualization compares the internal capacity of a standard single-aisle plane to a double-decker A380. By building upwards with a second deck and outwards to fit a twin-aisle configuration, engineers drastically increase the raw passenger volume per square foot of fuselage. High-demand routes between continents require brute force volume. By packing hundreds of seats into a single flight, airlines ensure these long, expensive trips actually turn a profit. Right alongside those massive people movers is a second, slightly smaller but highly advanced class of wide-body jets, the next-generation long haulers. The Boeing 787 and the Airbus A350 define this category, operating as the most modern twin-engine aircraft on the tarmac. This structural breakdown illustrates the core engineering shift. Instead of heavy aluminum grids, manufacturers transition to lighter composite carbon fibers. Stripping thousands of pounds creates extreme fuel efficiency, allowing the aircraft to stretch a single tank across vast oceanic distances. Hong Kong's home carrier, Cathay Pacific, uses these highly efficient airframes to connect the island directly to cities like Paris and Auckland. Those ultra-long, non-stop routes are notoriously difficult to monetize without the steep drop in operating costs these specific planes provide. While the high-density Titans solve the problem of pure passenger volume, these composite aircraft solve the geometry of the globe, using material science to shrink the extreme physical distances between continents. The final component of Hong Kong's air traffic is entirely dedicated to physical goods. Massive freighters share the runway equally with the passenger fleets, moving cargo around the clock. While the Boeing 747 is rapidly disappearing from commercial passenger routes, it completely dominates the cargo tarmac here, flown by operators like Cargolux, Nippon, and Polar Air. This technical schematic demonstrates why the 747 remains the king of cargo. Its specialized hinged nose cone lifts out of the way for a straight-in loading path. Ground crews can slide massive industrial goods directly into the main deck, bypassing standard side-loading limitations. This shadow fleet operates as the invisible arteries of the global economy. They move oversized, heavy physical goods out of Asian manufacturing hubs at a scale and speed that no other airframe can handle. When you pull back and watch this airport operate, you see a continuous, overlapping rotation of these 3 distinct aircraft classes. Every massive widebody that rotates off the tarmac is a carefully engineered tool applied to a very specific logistical mission. By combining raw passenger volume, composite material efficiency, and specialized cargo architecture, this tiny island territory acts as a central pillar for global logistics. Watching these planes take off is a direct view into the mechanical heartbeat of modern trade. It is the massive, continuous choreography required to keep the global economy connected.